Good morning, everyone. It's a pleasure to welcome you to the Colegio de Ingenieros de Caminos, Canales y Puertos for the second edition of the Concreto Day organized as part of the Concreto Academy program. We are delighted to be joined today by the project members, partner companies and collaborating institutions representatives, the students participating in this edition, as well as colleagues and friends who accompany us on this special occasion. To formally open today's event, we are honored to count on the presence of the Concreto Spanish partner representative who will now share their opening remarks. Let me begin by inviting the President of the Colegio de Ingenieros de Caminos, Canales y Puertos, Miguel Ángel Carrillo.
Good morning. Muchas gracias Esther. Buenos días a todos. Para luego el Colegio de Ingenieros de Caminos, Canales y Puertos, pues un placer el tener aquí el segundo evento público del proyecto concreto, y de luego para nosotros es un orgullo tener hoy esta celebración en esta casa. Quiero primero agradecer a José Miguel Atienza, el director de la Escuela de Camino de la Universidad Politécnica de Madrid, a Elena Guijarro, que es la vicepresidenta del Consejo de Arquitectos, y tenemos también a Beatriz Oliete de la Fundación Laboral de la Construcción, pues que estén aquí con nosotros. Así que muchas gracias por vuestra participación y vuestra colaboración en el impulso de esta iniciativa que tenemos aquí en España. Quiero agradecer también, como no, a la Dirección Internacional del Colegio y en su nombre, encabezada por Esther, por este ahijado, pues todo el esfuerzo y el impulso que ha dado también para que podamos celebrar este acto aquí en el colegio. Quiero también, ya para terminar los agradecimientos, pues agradecer a todos los ponentes que hoy van a participar en esta sesión, en la que, desde luego, a muchos de ellos, desde luego los conozco, son todos unos grandes expertos en este tema, y además se va a tratar de un tema de una restauración histórica del mercado de frutas y verduras de Legazpi, del cual no es que tenga mucha relación con el mercado en sí, pero sí que lo he vivido porque yo empecé a vivir en Madrid, allí cerca de Legazpi. Así que para mí también es un tema un poquito especial. Bueno, hoy congregamos en este acto de luego a estudiantes profesionales, a técnicos, a expertos de múltiples disciplinas, en un encuentro que pone en valor algo que puede que no esté tan actual, pero que de luego es fundamental, que es el hormigón. El hormigón es este material que contribuyó desde luego a la modernización de España y prácticamente de todo el mundo, y del cual hemos tenido y seguimos teniendo grandes expertos con su trabajo, entre ellos nuestro querido Eduardo Torroja y añorado Eduardo Torroja. El hormigón es un material noble, es versátil si se hace bien, es resistente, de luego duradero y moderno. Palabra que creo que es importante porque, ya digo, ha sido un poco denostado este material. Ha sido protagonista en el desarrollo de nuestras infraestructuras y, gracias a su adaptabilidad, eficiencia energética y fiabilidad, sigue siendo clave en el contexto actual de transición energética y sostenibilidad. El hormigón también conforma un lenguaje expresivo propio en diseño y construcción de infraestructuras. Así lo entendieron nuestros maestros más ilustres, como el que he mencionado también, Eduardo Torroja, que fue un referente en su uso e innovación y cuyo legado ha inspirado a otros ingenieros de caminos. El hormigón, un material utilizado en todo el mundo, hoy sigue evolucionando para responder a los grandes retos contemporáneos, como la resiliencia ante el cambio climático, el envejecimiento de las infraestructuras o la eficiencia en la gestión de recursos. El proyecto concreto, en el que participamos junto a socios de Italia, Países Bajos, Bélgica y Turquía, representa un modelo ejemplar de colaboración interdisciplinar e internacional. Su enfoque formativo, su vocación por compartir conocimiento y su apuesta por la rehabilitación sostenible del patrimonio construido europeo lo convierte en una iniciativa de enorme valor. Nos enorgullece participar en este proyecto y, en particular, en Concreto Academy, en el que 30 estudiantes de Italia, España y Turquía están viviendo una experiencia académica y profesional, pues diríamos que única. Quiero animar a este grupo de jóvenes a que aprovechéis al máximo estos días de formación, de las visitas técnicas que estáis realizando y del contacto directo con estupendos profesionales de primer nivel. Desde el colegio entendemos que esta parte de asociacionismo es importante para impulsar el progreso social. Creemos que proyectos como el Concreto permiten avanzar más y mejor tendiendo puentes entre países, disciplinas y generaciones. Por eso estamos convencidos de que el trabajo que hoy vamos a participar y compartir servirá para inspirar nuevas iniciativas, para fortalecer nuestras redes de colaboración y para seguir defendiendo una ingeniería de caminos, canales y puertos más innovadora y sostenible. También estamos seguros de que esta segunda edición será aún más fructífera que la primera y que la siguiente, que ya está en el horizonte, va a servir desde luego para consolidar esta red y para impulsar nuevos proyectos europeos en la misma línea. Pero espero y deseo que esta jornada sea muy fructífera para el trabajo, para el aprendizaje y el intercambio de conocimientos. Y desde el Colegio de Ingenieros de Caminos, Canales y Puertos tendemos la mano a todas las asociaciones e instituciones participantes para seguir colaborando en la construcción de un mundo mejor. Muchas gracias.
Thank you very much, Miguel Ángel. Now I have the pleasure of inviting José Miguel Atienza, Director of the Escuela de Ingenieros de Caminos, Canales y Puertos of the Polytechnic University de Madrid.
Thank you. Good morning, everyone. Thank you very much, Miguel Ángel, for inviting me to be here today. And thank you, Leonardo, for including me in this event. Welcome to all the participants and especially to the international ones. We are all here because we recognize something fundamental for the future of civil engineering and to any serious sustainability strategy, the conservation and rehabilitation of existing infrastructures. As engineers, we tend to focus much of our effort, and rightly so, on designing new and improved structures. However, a truly sustainable vision also requires us to look at what has already been built. Extending the service life of our infrastructure is not just an efficient option, it is an environmental, economical, and ethical necessity. The field of structural heritage conservation will become one of the major areas of professional development in the coming years. And our engineers will be called upon to play an increasingly vital role in this field. It's not just about preserving the past, but about managing with intelligence and rigor the structural legacy that supports our present and shapes our future. Our school has long been aware of this need and has been a pioneer in specialized training in this field. For years now, we have offered some specific courses on the conservation of existing structures, both in the Master in Civil Engineering and in the Master in Structural Engineering, preparing our students to face this technical and social challenge with confidence. I see several of our professors here. In this context, we must not forget that reinforced and prestressed concrete structures make up the vast majority of our built environment. In the case of bridges, for example, it is estimated that approximately 2/3 in Spain are based on these typologies. Conserving, rehabilitating, and optimizing this infrastructure will be one of the great challenges of civil engineering in the decades ahead. Our school remains firmly committed to this area of work, and we will continue to be actively involved in European projects related to this topic. We are fully open to collaboration with institutions, universities, and companies that share this approach and this awareness, because conservation is also a form of innovation, and because sustainability lies not only on the new, but in knowing how to preserve wisely what we already have. And in that spirit, we have had a great pleasure this week welcoming a group of students and professors from Milan and from Ankara who have shared with us their experience, knowledge, and perspective from a variety of academic and professional backgrounds. It has been an exceptional week marked by interdisciplinary collaboration, exchange, and a shared enthusiasm for learning together. To conclude, I would like to offer a very special a very special thank you to the Pierluigi Nervi Foundation, the true driving force behind this initiative, for its ongoing commitment to the protection of modern structural heritage. And of course, to our colleague, Professor Leonardo Todisco, for his outstanding and generous organization, which has made this unforgettable experience possible for everyone involved. Thank you very much, and I hope you enjoy the day. Thank you for coming.
Thank you so much, José Miguel. We now welcome Ms. Elena Guijarro, Vice President of the Consejo Superior de los Colegios de Arquitectos de España.
Good morning. Buenos días a todos y a todas. Es un verdadero honor poder presentar hoy Concreto, aquí en esta sala con todos ustedes, un proyecto europeo liderado por la Fundación Pierluigi Nervi, que nace del encuentro entre la arquitectura, la ingeniería, la formación profesional que une entidades de Italia, España y Turquía y Países Bajos, en un esfuerzo conjunto para avanzar en el conocimiento, la preservación y la puesta en valor del patrimonio arquitectónico moderno. Concreto no es solamente una plataforma de formación o un marco de colaboración académica, es sobre todo un espacio de entendimiento entre disciplinas tradicionalmente diferenciadas, pero profundamente interdependientes en el proceso de concepción, desarrollo y ejecución de un proyecto arquitectónico. Arquitectos, ingenieros, profesionales de la construcción, técnicos y formadores trabajan aquí codo con codo compartiendo saberes, experiencias y herramientas. Esta colaboración interprofesional no solo mejora la comunicación entre agentes, sino que permite que el proyecto, desde su fase inicial hasta el final, se consolide de manera más eficaz, con una visión más rica, más inclusiva y más consciente del entorno en el que se debe inscribir. Pero hay otro pilar fundamental que sostiene Concreto Academy, su dedicación a la visibilidad y a la protección del patrimonio moderno construido en hormigón visto. En un momento, como se ha comentado, en un momento en el que muchas de estas obras del siglo XX comienzan a mostrar signos de deterioro y en el que el material del hormigón parece que no está bien visto, se hace imprescindible no solo rehabilitar todas esas obras, sino entender su valor cultural, técnico y simbólico. Estamos en un momento en el que empezamos a necesitar proteger la arquitectura contemporánea, porque hasta ahora estamos acostumbrados a proteger lo antiguo, a proteger las catedrales, los castillos, las construcciones, pero tenemos un patrimonio arquitectónico inmenso en hormigón, en arquitectura moderna, que desde aquí y desde los ámbitos donde los organismos oficiales estamos, tenemos la obligación de conservar y mantener. La arquitectura moderna es memoria construida y la reciente es la memoria última. Ahora más que nunca debemos asumir la responsabilidad de proteger, restaurar con sensibilidad y sobre todo visibilizar como parte esencial del legado que dejamos a nuestras futuras generaciones. Por eso, Concreto Academy también es una invitación a mirar el hormigón no solo como material, sino como lenguaje. A leer en esas estructuras las aspiraciones de una época, a cuidar desde la técnica, pero también desde la emoción, esas piezas que nos hablan de progreso, de comunidad y de futuro. En nombre de todas las entidades que forman parte de este proyecto, quiero agradecer profundamente el compromiso, la energía y la visión compartida. Estamos construyendo juntos una red de conocimiento, de respeto mutuo y de amor por la arquitectura. Y eso en sí mismo ya es una forma de legado. Muchas gracias.
Many thanks, Elena. To conclude this round of opening remarks, I invite Ms. Beatriz Oliete, Head of the International Projects Department at the Fundación Laboral de la Construcción, as Mr. Javier González, Director of Training and Employment, due to an unexpected last-minute issue, is unfortunately unable to join us as originally planned.
Hello, good morning, everyone. Welcome to this event. Thank you to the hosting partner, the Colegio de Ingenieros de Caminos, and thank you to our coordinator, the Fundación Pierluigi Nervi. I'm sorry because I'm going to do my intervention in Spanish because I was told that it was going to be in Spanish, so I haven't prepared it in English. I can improvise, but I prefer to do it as what I have prepared for today. I represent Fundación Laboral, as Esther has just said, and I'm the head of International Projects Department. La Fundación Laboral de la Construcción es una organización sin ánimo de lucro, es una entidad paritaria formada por los empresarios del sector y los sindicatos del sector y que desempeña un papel fundamental en la mejora de la cualificación de los trabajadores del sector. Nacimos como fruto del diálogo social entre empresarios y sindicatos y nuestra finalidad es promover un sector más cualificado y más seguro. Por tanto, nuestros pilares fundacionales son la cualificación y formación, la prevención de riesgos laborales y también la empleabilidad del sector. Llevamos en la Fundación más de 30 años impartiendo formación profesional, tanto formación profesional inicial, los ciclos de formación profesional reglada, como formación profesional continua, fundamentalmente cualificando y recualificando a trabajadores que ya están en activo o desempleados en el sector, para dotarles de la formación en las últimas tendencias o en las últimas necesidades que tiene el mercado de la construcción. Además de esa formación, tenemos un departamento de proyectos internacionales que nació hace ya casi 20 años, del cual soy coordinadora y del cual están aquí mis compañeras, Matilde de Ganzo, que es la que está involucrada en el proyecto concreto. Y bueno, pues tenemos un bagaje y una experiencia a nivel europeo e internacional en el desarrollo de formación profesional, así como una amplia red de contactos, suficiente como para saber que este proyecto es un proyecto especial. Con todos los proyectos en los que hemos participado, he de decir que este tiene algunas características bastante singulares. Para nosotros la principal diferencia es que forma y une a chavales, a estudiantes, chicos, chicas, que son de diferentes ciclos, de formación superior y también de formación profesional, promoviendo el entendimiento entre los diferentes oficios para que no se pierda el mensaje de aquello que se quiere hacer con eficiencia energética o que se quiere hacer con criterios de ecología y medio ambiente. Además, el proyecto concreto ahora mismo trata sobre algo que es trending topic gracias a la película El Brutalista, así que no puede ser mejor y más oportuno. Una de las características que tiene fundamental también este proyecto es el hecho de que para los alumnos fomenta muchas competencias transversales, algo que no es habitual en muchas de las formaciones, pero al conseguir que alumnos de diferentes países estén trabajando juntos y alumnos de diferentes bagajes educativos y de diferentes niveles educativos estén compartiendo esa experiencia formadora, implica que pueden mejorar su comunicación, el trabajo en equipo, la gestión de proyectos, resolución de problemas, habilidades que son cruciales para adaptarse a los cambios constantes del sector de la construcción. Nada más por nuestra parte. Muchas gracias por invitarnos a este evento, muchas gracias por invitarnos a participar en este proyecto y espero que sea fruto de más colaboraciones en el futuro. Y nada más, gracias por vuestra atención.
Thank you, Beatriz, and thank you all for your opening words. And once the session has been formally open, I kindly invite you to take your seat in the auditorium so we can continue with the program. And it's now my pleasure to welcome to the stage Elisabetta Margiotta and Irene Matteini, who will introduce the Concreto project. Elisabetta and Irene are the truly heart and soul of this initiative. From its very conception, they have brought a bold and innovative vision and tireless dedication, from shaping the consortium and securing funding to leading the implementation of the program with remarkable commitment. Please welcome Irene Mateini, Scientific Director of the program, and Elisabetta Margiotta, Project Coordinator.
Thank you. Thank you, Esther. Thank you for inviting us in this beautiful environment. We are thrilled to be here, as you already know. And I have to say this second Master Youth Skills is really going along very great. We have a fantastic group of students and who is truly responding to the offer we are presenting them in this project. And I really wanted to thank the speakers we had before us because they pointed out two elements that are really relevant for our project. And one is the memoria construida. We were talking about that, the built legacy, the built memory that modern heritage represents for us. It's part of our history, of our identity, our European identity, which we really care about. And then also the fact that conservation and preservation are innovation. So to present to our future generation this kind of skills is very important for us. And we are very thrilled to be here. And thank you again to all the partners of our project who are really, really, truly believing in it. And we are really grateful. Thank you.
Buenos días a todos. Muchas gracias por de caliente bienvenido. I have to apologize, but our Ital Spanish is a little limited, so we have to switch to English. But we're very thrilled to be here, and really was a really nice welcome, and really a particular thank you to Esther, the Colegio, and all the Spanish partners. They have been really put an incredible training program, and we have had really a great time here in Madrid. This is our second year, second Concreto Day. We have just spent 8 days here in Madrid, completing our first in-person training activity. With this occasion, I would like to invite the guests today to then, during the break, to really interact with our participants and also our partners that have come here from Italy, Spain, the Netherlands, Turkey, Belgium, to really gather here for this yearly event that we have. The past week for us was about learning, exchanging knowledge, meeting experts, and really making valuable connections. We have been, we were hosted by the Universidad Politécnico de Madrid with really a special thank you to Leonardo for his dedication, for his enthusiasm and professionalism, and his team, Rolando, Julis, that have really provided really great training and really great effort. It has been a really enriching experience learning from our Spanish colleagues, and that's what really makes European project really great, because they give you really a platform, an opportunity to exchange knowledge. Students had the opportunity to work together, to collaborate in different assignments. We met local and national experts, discover companies, research center, like you see here. We had the opportunity to be hosted by the prestigious Instituto Torroja, and a really special thanks to Matilde, to Beatriz and Fundación Laboral for arranging this great visit, and really several companies and other organizations that they hosted us. As part of the Concreto family, we always have to have fun while we work hard, and indeed we had some time to explore. We had a fantastic trip to Toledo that was very nicely curated by Sergio and Natalia, and then indeed the students had plenty of time to party and have fun in the meantime. By now, you're probably wondering who we are, right? What is Concreto Academy about? For Spain, I have to say we did pick the right word, the concreto, which really refers that we're working with indeed concrete. But jokes aside, Concreto Academy is a European-funded project, is an alliance for enterprise and education, and I really want to underline the word alliance because it is really one of the goals that we have been trying to achieve. We were selected as Pierluigi Nervi Foundation. We are the project coordinator in 2023, and we were able to launch the project at the beginning of 2024. As you know, in every great project, there is always a great team behind. The Concreto Consortium is what makes really this project a really fun and incredible experience for all of us. We are the project coordinator, but it's a very large consortium of 13 partners representing 4 European countries, Italy, Belgium, the Netherlands, Spain, and indeed our Turkish partner. Very important, what we have tried to do with the Concreto Academy is to bring together all the different actors, profiles, and professionals that are involved in this type of work to really sit and collaborate and really force this dialogue to sit at the same table. So as you notice here, we start with Modern Heritage Organization, with us, and then Docomomo International. We have then University, the Academia Award, with Politecnico de Madrid, Milano, and METU in Ankara. We then have the vocational training organization, craft schools from Italy, Fundación Laboral here in Madrid, and MIC from Turkey. And indeed, we also have the national organization that represent architects and engineers in each of these countries. So as you see, as a pretty diverse set of expertise that really, they all play an important role when we think about concrete conservation, concrete rehabilitation, retrofit of our existing structures. Together with this, the consortium also includes a numerous technical sponsors and partners, including local partners that have really contributed immensely to this project, and we have some of them that have come here today to show some of their product and indeed equipment. We started last year in January. We just celebrated 2 years. We can put 2 candles. We now started a little bit to learn how to walk. This is a 3 years project. Every year, 30 new participants are selected from Italy, Spain, and Turkey. We work in 1 UNESCO site in Italy, which is the Olivetti town of Ivrea, between Milano and Torino. And then who takes part in this project are architects, conservator engineers, craft workers, and contractors. The mission behind this project was really driven by, was conceived as a training program, as a training school, focusing on conservation and rehabilitation of good quality concrete architecture, providing the right skill set that are needed to work in this field. The core value of this project, which it's very unique, it's really based on the learning by doing, getting their hands dirty, and really on the practical approach. It's really more conceived as a fellowship, as an apprenticeship, than really a more not so formal education in a way. And the ultimate goal for this is really to bridge the gap, to create a dialogue between, on one end, the academia world, which provides us the great formal education that most of you in this audience have, with the professional world, with the practical. Because as you know, because you're probably involved in this type of work, the success of our intervention relies on the quality of what happens in the field. So this is a very important aspect of this project. The background, as Elisabetta a little bit, and really the previous speaker, which gave a really nice welcome, hinted, is that why we decided to develop this project. On one end, we were moved by the safeguard and the protection for modern architecture, modern heritage. On the other hand, responding to urgent European policy to renovate and really work with our existing built environment, and really more simply that we have a very large portfolio of concrete buildings, concrete infrastructure that are getting older and are in need of our help. Nobody can deny that this unique man, the work of Pierluigi Nervi, has indeed been one of the main inspiration of this project. Certainly brought me back to Italy from the US to work on Nervi, so I think for me, did the trick. But indeed, you know, Nervi left us an incredible legacy. The foundation was established in 2008 by Marco Nervi, which is hiding in the audience. We will point him out in a little bit, and indeed Elisabetta. And the past 2 decades, they've really worked really hard to promote, protect, and preserve Nervi's work, but not only. And since we are in Spain, I couldn't resist to honor and really show my admiration for another great visionary and engineers that, you know, how that is really Eduardo Torroja. It's a very hard pick. When yesterday we went to see the Ippodromo La Zarzuela, I really felt I was cheating on Nervi a little bit because I don't know, it's really hard. Genius at the same. Exactly. Genius to different, in different ways, but definitely that they have contributed to our concrete architecture in incredible ways. So now this is what I call the concrete clock. Everywhere in Europe we have thousands and thousands of concrete buildings, which only 10 or so represent listed or heritage building in this moment. We hope that the list will increase, but the moral of the story is that we have a lot of building, good quality architecture that have contributed to build our modern city that are now old and need our help. We believe that this material was eternal. Unfortunately, it wasn't. Time is ticking, and we have a lot of work to do. Not only, but concrete today is the most widely used substance after water, and indeed the 3rd largest carbon dioxide emitter in the world. Any study of concrete today, past, present, and future, must indeed consider contemporary concern for retention and reuse of what has already been built and the industry ecological transition to greater sustainability. Despite the great progress that we have achieved in the last 200 years since the introduction and the patent of Portland cement, which we celebrated in 2024, 200 years, the concrete technology has advanced greatly as a material that has really allowed us to build significantly our city, but it's still worthwhile, very disappointing when we look at stats on how we are doing with our intervention in terms of repair, durability, and indeed performance. I think in this audience we can fairly say that we can split a little bit the blame between the design professionals and the people that actually do the work in the field. For this reason, we reflect that working with this material, although very economical and very versatile, it requires a very specialized set of skills. It's artificially made, it's made in the field, which on one end gives us incredible opportunity, but on the other really underlines and always is a good reminder that relies a lot on the quality of the craftsmanship. So it's very important. And as we are faced with intervening in this architecture, thinking about, you know, this type of specialized skills is incredibly important. And so here we are, these are like this, after this, you know, a little bit background, this is what has been really the goal behind this project, to really bridge the gap between practice and research, to give a practical approach, to show how things are done, to allow professionals that specialize, that design intervention to really have an opportunity to really see how, what it takes to do a patch repair, which is still today quite a challenging task. All the teaching and training activities of Concreto revolve around what we say the 5 skill pillars of knowledge, the A to Z of what it takes to work with existing concrete structure, starting from, you know, concrete assessment and then along moving to touching upon all the different type of techniques. Who participates in this, who takes part in this project, and they're all sitting in this room. There are students from architecture and engineering schools. There are students from VET organization, craft schools, that are going to be the technician in the field of tomorrow. And then there are young engineers, young architects that are already working in the field. The Concreto journey, how we refer, is a one-year program. We are not meeting every day. It's not a continuous 360 concrete full immersion. We have 3 appointments during the year. We start with an online introductory training where we first get to know one another. We introduce some of the big challenges, some of the main topics through case studies. This year we started in January. Then we are here now. We are about to complete our Master Your Skills, the 8 days, the hybrid learning. Last year we were hosted by our partner in Madrid, in Milano, at the Polytechnic of Milan. This year we're here in Madrid. And the Concreto Master Your Skills is where we have frontal lectures, but we are starting to add field and, laboratory exercises and field visit. We come to the end, to the summer. That is our summer camp, is our field training in Ivrea. Indeed, it's a place where in the summer is very hot, and there is no beach around. So at the beginning wasn't an easy place last year to convince people that was the right place, especially Italians, to come in August in Ivrea. But we managed, and this year we moved a little bit early. But what we have been trying to do in Ivrea is that Ivrea, it's a UNESCO site, is the iconic factory town of Adriano Olivetti, probably one of the greatest entrepreneur of Italy of the last century, that developed indeed one of the iconic typewriter. And the UNESCO site was declared in 2018, and the idea of organizing this course at the site is that the work that is done through the students, that they can use this campus as a gym, contributes in the end to the conservation of the UNESCO site. Why? How do we do this? So in Ivrea, the activities are organized into, they take part in two main areas or part of the campus. On one end, we select a case study, a patient that we find some really nice willing owners that are they open their doors to us. And last year was this quite neat brutalist building to the top of the screen. This year we are going to use another patient, but in the case study we primarily do diagnostic, and it's an opportunity for students to work in teams and really start to think what are some of the problems we have with concrete structure. And then at the same time, we have created a space inside the iconic Olivetti factory. Here you see a picture when before the student arrived. Indeed, it was not clean like this by the end of the course. We have built different sizes of mock-ups thanks to the collaboration of local contractors that have helped us. That really created this quite unique setting to where some of the practical classes take place. Here is a shot done by Korai, professor from METU, that took part last year, that was involved in the documentation phase and the diagnostic. Here you see students working hardly under the sun, trying to figure out how the building was built and what were some of the pathology that we identified. Through as we mentioned, the activities are all hands-on, are all field activities. These are some of the photo of the work that they did at the building. So they start really from archival research, and then they were assigned different parts of the building where to really identify how the building was built, and then continue to do some of the most common diagnostic testing that are usually done when working with concrete. After spending a week in the sun, we brought them back inside in the laboratory with no air conditioning. where we really started going through the basic of, how concrete works and making some concrete, what it takes to change ingredients, what it takes to really, how difficult in reality is then to work with this material. We also put Marco to work, as you see here. We had to have a kind of the blessing from an RV before we really got going. These are some additional exercises working with both, dealing with how to match, how to work when replicating historic concrete. To really, we have Matteo here trying to perform a patch repair that indeed now I think he can confirm that was not a really easy task. We also touch upon, electrochemical techniques and so on. So in the end, what is the sustainability of this project is a 3-year project. We are on the 2nd year. We have 1 more year as end goal of these 3 years. We have the publication of practical guidelines that are referring to the different type of intervention and assessment for concrete, and also the production of very short online massive open source courses that will be on an open source platform. And then, as you can read there, the future is also to continue to be able to independently continue to do this as a training institute.
We should maybe mention the code book that will be getting out.
Yes, we are also very, very close to publish one of the first product of it's really a research of state-of-the-art and literature review that was done from the starting of the project in try to really understand the gaps, what are we doing well, what are we missing, and of course we have to call out Guido from Docomomo because they were leading this effort and they have done really a great job. We are getting closer to publish it. You will all receive part of the newsletter, the link, so stay tuned. We are not gonna let Guido leave Madrid until we have a proper final date on that. Concreto, we have also continued to reach and, as part of the outside the European borders, we have tried to also continue to build international connections and network with other institutions across the world in order to really expand and make it even more international than just really left to Europe. With that, I think as we enter the 2nd year, one of the goals of Concreto is really to build a strong network of collaboration and partnership. I would like to point out in the public that today we have alumni, we have participants from last year from Italy, Spain, that have joined us here today, so they are continuing to follow the Concreto family. And I look at all of you participants that really the main goal is really the future is to improve this field and really to improve our best practices across Europe and more. So the world is your oyster. We're open to collaboration, so please reach out, and we are very glad to be here. And again, a special thanks to all the Spanish partners that have really made this first in-person training really memorable and great. Thank you so much, and don't forget to follow us. Thank you.
Now I think that further to the presentation of Irene and Elisabetta, we have a video of the Concreto project that will give you a further idea about this. So,
Concreto is an alliance for enterprises and education project under the Erasmus Plus program launched in January of 2024. Led by the Pierluigi Nervi Project Foundation, the Concreto Consortium includes 13 partners from Italy, Spain, Belgium, the Netherlands, and Turkey. comprising of higher education institutions, vocational training organizations, national trade associations, and modern heritage organizations. The project draws inspiration from Pierluigi Nervi's architectural legacy and focuses on developing skills for the green rehabilitation of concrete architecture. Inspired by the Renaissance idea of the arte shop, La Bottega, Concreto is conceived as a training school combining theoretical learning with hands-on practical experience. Each year, Concreto brings together university students, craft workers, and young professionals to learn and collaborate together, aiming to bridge the gap between academia and the professional world. Concreto identified 5 skills pillars of theoretical and practical knowledge for professionals to master when engaged with the rehabilitation and regeneration of our concrete buildings. The teaching and training activities are organized in 3 sequential units around the 5 skills pillars as Concreto workshops, intended to link education with practical sessions. Starting with the Concreto stepping stone, then followed by the Concreto Master Your Skills, and ending with the Concreto Masterpiece, the final summer school with 100% hands-on fieldwork experience, which will take place at the UNESCO site in Ivrea in Italy. The Concreto Academy supports the two-way approach of principle and practice, promoting smarter and greener renovations to ensure the safeguard of our concrete quality architecture. The Concreto Academy seeks to equip today's professionals with the skills needed to become tomorrow's expert in sustainable building practices. And remember, our European concrete quality building stock is a non-renewable common good, whose preservation and empowerment are the responsibility of society as a whole.
Thank you very much, Irene and Elisabetta, for your inspiring presentation. And let us now continue with the technical part of our program. And for that, I would like to invite to the table to the speakers from our first 2 case studies, Eduardo Díaz Pavón, Javier León, and Juan Jesús Álvarez. So I will introduce our first speaker, Eduardo Díaz Pavón. Eduardo is a doctor civil engineer, graduated in 2003. He has developed his professional career at Intemax Structural Pathology Department, specializing in diagnostic and evaluation of structures, particularly after extraordinary events such as fires or earthquakes. He has worked on a wide range of historical and modern constructions, driven by his passion for the construction technologies and built heritage. Eduardo has contributed to numerous technical publications, including books and conference papers, and lectures in postgraduate programs on heritage rehabilitation. Today, he will present the case study of the restoration of the fruit and vegetable market of Legazpi in Madrid. So, Eduardo, the floor is yours.
Thank you very much, Esther. Can you see me? No. And now it's the same. No. Okay. Thank you very much, Esther, for your presentation. Welcome to Madrid. I'm sure you are enjoying the city. and congratulations for the project because it really looks very interesting and necessary. I'm going to tell you about some interventions in the Legazpi market that I will present now. I'll start with a brief historical background to follow with describing the market structure and talking a bit about the designer of the structure, Peña Boeuf. Then we'll focus on some structural works that have been carried out, and we'll try to take some conclusions. We have to go to Madrid in the 1920s, 100 years ago. You've been 8 days in Madrid, so you already know where is Puerta del Sol, where is Atocha, and in the south of Madrid it was still a suburb, and the city council decided to build wholesale markets where neighborhood markets could buy their products. The most known of them is the slaughterhouse, the Matadero. You've probably been over there, which is close to the river. Close to it, there was a site of the city council with this triangular shape because of the railway tracks, and it is here where the council decided to build the market. Matadero had been built in a regionalist style, using in Madrid the regionalist style used stones, bricks to make arches, etc. But the architect, Alberto Ferrero, decided to change completely this, and he used concrete to build the new market, and made another decision, which was to use completely the space in a very functional use, placing all the buildings in the edges of the triangle, leaving in the center a huge square where sales could be done. Here is Javier Ferrero and some views of the building in the edges of the site. You can see the section, and it is always the same. It's a very repetitive frame with large spaces and with no decorative. What includes it into rationalism style of architecture. Only in the second floor there are two canopies, quite large, we'll see later, that breaks this uniform architecture and structure. It was in use from 1935 until 1983, when another bigger market was built, which is Mercamadrid. From then until the beginning of this cycle, it was abandoned, and many damages and problems arose. The city has been growing, and now that suburb of the 1920s is a center of leisure and culture in Madrid. I already mentioned Matadero, but it is also Madrid and other places for leisure and culture. So it is important that this building here have any use. It is very important because I live here, so it's good for me. The idea of the project is to maintain the idea of Alberto Ferrero, which is that great square in the center and the buildings in the edges. Some views of the rehabilitation that is now in course, and as you can see, the structure is maintained, and it's the same that it was 100 years before. Some views with the new uses, and a question arises. It will cost 100 million euros. Somebody could say if it is worth it to have this inversion. I have no doubt, and in this context, nobody doubts, because of sustainability and heritage values that this building and this architecture have. But let's go with the structure, and we have to go to 1931 when the market was designed. It is interesting to see that although concrete was also a consolidated material, the structure is very similar to those of Enevic in the end of 19th century, with those frames, with the forms when they get to the column, with rib slabs, etc. They are very similar structure. Of course, those patents have been passed, and structures like those of Freysenet or the roofs of the German engineers, Astinsinger, etc., have been already built. And in fact, Le Corbusier had published through a new architecture and concrete, and had embraced concrete also for architecture. In Spain, the situation was quite similar. At the beginning, we used patents, mainly from France. Ribera was the engineer who introduced most of them. And from 1910, concrete was taught in the school, in the Polytechnic of Madrid. After Ribera, many engineers came. You already mentioned Torroja, but there were many others. But I don't want to forget the author of the mercado, of the market, which is Alfonso Peña Boeu, that, for example, participated from the administration in the control of this great viaduct in Alcoy, San Jordi Viaduct. In one thing, we were a bit delayed respect Europe, which is the codes. Because in Spain, we didn't have any code until 1939, after the Civil War. Until then, we used the codes from the rest of Europe, mainly from France. Alfonso Peña, that I mentioned before, was a civil engineer. He had teachers like Zafra, who was the first teacher of concrete in the Politécnica de Madrid. And when Zafra died, he took his chair of concrete. He published many books that has been a reference for many engineers in Spain, and but that he didn't have many projects. But he imagined many projects. He didn't say, but he was a dreamer. And for example, it surprised me when I studied him by the first time, that, for example, in the 1930s, he already dreamed a bridge over the Gibraltar Bridge, which surprised me. That surprised me. Another interesting information about Alfonso Peña is that he was the Minister of Public Works in Spain after the war. Today, Carlos Polimón, which is an expert in bridges in Spain, is not going to speak about bridges, so I'm going to tell you about a curiosity of Alfonso Peña, which is that in 1932, he designed an aqueduct in the north of Spain, in Tardienta, but his partners didn't like the design, and they had doubts about the security of the aqueduct. He made models to prove that it was correct, but because of the war, this project was stopped. After the project, they made some proof loading, and they checked they were right, so they could build the aqueduct, and it was the Prime Minister who inaugurated his own work, which never happened in Spain. This structure is very similar to that of Torroja, of Alot. It is much more elegant, this other one, but maybe Alfonso inspired Torroja in the beginning. let's go back to the market, and it's a structure, and as you can see, it is a very robust structure. Mainly in the central corridor where vehicles had to go to distribute the food or whatever. In the roof, there were these canopies, which are 6.5 meters. It's quite a lot. In fact, the first time I had to check the structure, I didn't know how it worked. And I didn't know how it worked because I didn't think that an engineer then could design this by torsion. But it wasn't like that. He designed many reinforcement by torsion to resist this canopy. But the main problem of the market for the restoration has been carried out are the foundations. As I mentioned before, and as you can see in this picture, the market is close to the river. Alfonso Peña knew the soil was not so good, and in fact, he designed troncopyramidal footings so that the tensions in the soil were low enough. Despite this precaution, many damages appeared in the facades and also in the structure. I don't want to be very technical, but I can't resist to explain some of these damages. For example, these ones. As you know, at the end of a frame, you have negative moments that compress the bottom part of the section. So, in the beginning, it is not necessary any reinforcement in the bottom side. But every code recommends or establish that you have to put 1/4 of the reinforcement of the bottom into the column. This is because you can have a change of the moments, for example, because of settlement. And here it's clear. If you have a settlement, positive moments will make tensions in the bottom reinforcement, will tension the reinforcement that you need in that point. If you don't have it, or how in this case you have, but it is not enough, great cracks appear, and they have to be treated. Because of these kind of damages, because of the new uses and new floors in the market, and underpinning had to be done in all the foundations. It was decided to do it by micropiles, and the problem of this kind of intervention is to take the loads from the column to the micropiles. In the beginning, if the loads are not too big, we can do it inside the existing footing. It means we have to check that the bond between the micropile and the footing is high enough, and that the tensions that are generated in the footing are also low enough. This was not the case in most of the footings of the market, and other solution had to be found. As there was not any problem of height over the footings, we decided to make caps over the existing footings. But the problem is the same. We have to take the loads from the column to the micropiles. And to do this, we have different mechanisms. The first one is just shrinkage. Because of shrinkage, there will be compressions against the column, and this will improve the bonding between the column and the cap. If we don't trust in this shrinkage, we can analyze the reinforcement. We can place analyzing shear friction, which means that when the column tries to bond, to slip inside the the footing, the cap in this case, the reinforcement will be in tension, which means that there have to be compressions against the column. Okay? If not, another solution is to pre-stress that cap. And this is the only solution in the case of the facades, as you can see here. I don't know if you can see the point, but here is the existing footing, and this is the new cap that is pre-stressed, and so that there are compression that improve bonding. This solution was also used in the interior columns. Here you can see the execution of the micropiles, the placement of the reinforcement, concreting, and then pre-stressing. Here another doubt arises, because once you pre-stress, you don't know what you are pre-stressing. What you want to do is to pre-stress the cap against the column, not the cap itself. But, well, they decide to do this, and as other mechanisms works, it's enough for us. These interventions meant 15 million euros. It is a lot, but it is not so much if we compare it with the amount that the council wants to save because of the booking or of renting of other buildings. All the people will come here, and they won't have to rent other buildings. Another interesting intervention was the closure of the joints, which was a problem in the market. Here you can see two cases of joints that were very bad resolved, and in fact it's difficult to understand how this didn't fall before. Probably because these beams were supported by other elements, probably facades or something like that. In other cases, in most cases, in fact, expansion joints were resolved doubling columns, and the configuration was right, but because of the problems of the foundation that I mentioned before, there were some cracks. In both cases, we decided to eliminate the joints and to change the structural behavior, so that placing new reinforcement in the top side of these elements, so that new reinforcement will be which work against new loads. Of course, this kind of intervention must be analyzed, and it is interesting to see that when we modeled the frame without these joints, the movements that result are quite similar to those that the market had with free deformation. And it is because for very low change in temperature, the supports will crack. And this means that the stiffness of the column will be reduced, and it allows to have the deformation. In fact, the moments in the supports were very low, and as they had a lot of ductility, because the loads are very low and the reinforcement, the amount of reinforcement is also very low, ductility was enough, and there was no problem because of closing the joints. Regarding to the beams and the slabs, closing the joints, they are now in tension, but the stresses were very low, and there was no problem. And in the point where we are closing the joint, of course, we have to place new reinforcement, but as you can see, it is not very much, and it was easy to place. Here is a detail. I don't want you to understand and to see everything, but it is interesting. Well, this is the detail, the two columns. Sorry. The two columns and the new reinforcement, and new other reinforcement needed because of the things. But the interesting thing of this image and also of these photographs, where you can see the hole in the column, the placement of the reinforcement, how this kind of work is done is that it implies very specialized skills, as Irene mentioned before. And that's why I wanted to tell you about. Finally, I wanted to talk about beams and slabs, where the problems were mainly corrosion problems, durability problems, but also fire protection, security in a situation of fire. I'm not going to speak about corrosion and durability because we have Carmen and Carlos after me, but I want to point out that in the assessment of existing structures, it's very important to distinguish with existing codes, because existing codes for design are thought to establish some requirements of geometry, of covers, that probably in existing structure you can meet. So we have to do a performance analysis to check if security, if functional needed are compliant or not. In this sense, I want to show you the situation of the RIPs of the market against fire. As you probably know, in those years, the reinforcement has had a sketch like this, with reinforcement in the top side close to the column, that go down to the bottom side in the center. In addition to that, covers were very low, and this can be a problem in a situation of fire. Why? As you also probably know, when you hit a beam, an isostatic beam, it will have a deflection, and the moments will be the same, no change in moments in the beam. But if this beam has continuity over the supports, this deflection is not free, and there will be negative moments that make that the law of moments will be increased, negative moments will increase. That's why in the design, in design codes, there is a sentence requiring that the length of the negative reinforcement must be longer than in other situations. To analyze this, we can have the isotherms in the section, which are the temperatures for a fire. Including these temperatures in the section and in a model, we can see how the negative moments are increased. But we are doing something wrong, and is that in this image, we are considering that concrete is the same that in design, no changes because of the high temperatures. But high temperatures means that the properties of concrete change, and in fact the stiffness of concrete is reduced from the very beginning when you heat it. If you take this into account, the increase of negative moments is really low, And if you compare the loads with the capacities, which are in red in this graph, it can be checked that the slab didn't need any protection against fire. Just to finish, some conclusions. The first one, the importance of understanding and respecting engineers, people, architects that have been before us in the works where we go. Second, the best reinforcement is no reinforcement. It's better to analyze it better to try to avoid reinforcement. Another conclusion is that in many interventions of this kind, the problem is not to assure security. The problem usually is linked with functional requirements and durability problems. And finally, we have to take into account that this kind of works are living projects. We can try to make the best project to make the restoration, but always there will be things in the works that will surprise us, and for that we need to be prepared. Nothing more. Thank you very much for your attention, and enjoy the rest of the day.
Thank you very much, Eduardo, for this extremely interesting presentation. If there's any questions in the audience, we are going to wait to do all together before the coffee break. So now we move to our second case study, focusing on the diagnosis and dismantling of the Francisco Silvela flyover in Madrid. And to present this, we have with us today our colleagues Javier León and Juan Jesús Álvarez. Thank you for being here. Javier León is a doctor, civil engineer, and professor at the Universidad Politécnica de Madrid, specializing in concrete structures and heritage preservation. His minimalist and respectful approach to rehabilitation has helped saving ionic structures as the Deva Bridge and the La Toja Island Bridge. A long-standing member of FECOR, Ingenieros Consultores, he's also part of the advisory council of the Juan Eloy Turriano Foundation, promoting heritage conservation through academic initiatives. Together with him, Juan Jesús Álvarez is head of the Bridges and Civil Structures Department at Dragados and president of the Events Committee of the Spanish Association of Structural Engineers. With over 30 years of experience, he has led complex infrastructure projects across the sector and is widely recognized for his technical leadership and innovative solutions. So Javier, Juan Jesús, the floor is to you.
Hello? Can you hear me? Okay. Well, now both Javier León and myself are going to tell you the sad story of a bridge, of this bridge, which died too soon, or not exactly, but a little soon. This bridge was here in Madrid, not far from here, 1.5 kilometers from this building. You can see some pictures of this bridge. It seems to be, watching these pictures, it seems to be a composite bridge because of the color of the girders, but it was really a distressed concrete bridge. You can see here the plan of the structure. It was a bit complicated because it had an alignment following the Francisco Silvela street and a connector making this Y shape. Please. Can you see the red dot? I don't think so. Yes. Yes. Okay. Well, we had this. Well, really, I don't see it. Sorry. Okay, much better. Hello, do you hear me? Okay. Well, we had this main part of the bridge over the Francisco Silvela Street and a connector here to the Príncipe de Vergara Street. The width of the bridge was variable. It has a complex shape. You can see in the picture on the right side that it was just in the middle of the city, with crossing many streets, and surrounded by many buildings. If we take the plan and we rotate it, we can see here the main deck, the connector, and then on the right side you can see the cross sections. It was stressed concrete slab with two cores and an upper slab in the main deck. The connector was narrower, 9 meters wide, so it has just one core and a top slab. The spans were variable, but the most repeated was around 34 meters long. Here you have some pictures of the first days of the bridge. It was constructed by the company, the construction company where I worked today, Dragados. It was constructed in 1970. Should you have any doubt about the construction of this bridge, you can ask that engineer, Jesus Rodriguez, who is there. Jesus, please. He was working here in the construction of this bridge. So, but you were working here. So you can ask anything, anyone can, any doubt they can have. Well, you can see there the young bridge, and many years later, Dragados was in charge of the contract of maintenance and refurbishment of the structures of the Madrid City Council, more than 300 structures. One of them was this. This contract will last from 2014. It lasted 4 years. We made a lot of maintenance actions in these bridges and these structures, and some of them, like this bridge, was refurbished. We have to refurbish the bridge. We fixed some problems, cracks and other things, and very important, we changed the waterproofing of the top slab to try to avoid water entering inside the bridge. Our intention was good, but I'm afraid it was too late because the bridge already was ill. That we saw that, we realized that a few years later. Now Javier is going to show you, to explain what happened with this bridge following.
Thank you, Ángel. Thank you, Esther, for your presentation. Thank you, Leonardo, for the invitation to participate here. You are the responsible of any disaster that can happen. Indeed, this bridge is the result of a very good project, a very good construction. This is important to make it clear. But this is the drawing showing the drainage. Drainage is very important in concrete structures. Water is good for human beings, for nature, but it's very bad for concrete. So any plan, any detail oriented to ensure proper drainage is very good. This is the first thing I wanted to say. The designer was José Antonio López Jamar, a very good engineer, perhaps not as very well known as others, but very very good engineer. The information we gathered, we made a clinic history of the bridge beforehand, exactly as medical doctors make with their patients. It's very important to study and to look for the story and to analyze it. Indeed, as Juan said, the structure is a very slender one, 1 meter in total depth. The slenderness is quite important, over the normal standards in that time even. The designer followed the Spanish standards of that time, and regarding pre-stressing concrete, only the French regulations that were available in that moment. The technology used in that time was the best one. The project is developed in 1968. The construction started in 1969. In that time, human being was in the moon, so the technology was very, very important. I would say it is normal. It's a current bridge from this point of view. It's a plan showing the layout of pre-stressing tendons, some anchorages here, but it is important to say that this was made in just 1 meter 20 centimeters height. So it was very difficult to ensure to provide the geometry. Those voids you see here, those voids with formwork on wood, was really difficult. It's necessary to recognize this situation. Another example, and this is a cross-section during the dismantling, or dismantling is the fine word to describe demolition. Demolition is a bad word, it's a sad one, but as Sigmund Freud said, you cannot avoid to have a bad government, you cannot avoid to have health problems, you cannot avoid in the schools to have students that fail. It is good to fail, otherwise some students could be public danger in the society. So it is important to bear in mind. This cross-section is one of the many that were carried out. You see some voids there, and you see also the displacement of the strands within the sheathing, showing that some problems had occurred in the past. Or the detail of the top tendons on the support area. It is important to say that the amount of pre-stressing steel was very high. The criteria at that time were very different from the current criteria today. So the excess of pre-stressing was about 33% in comparison with the current criteria. On the contrary, the amount of mild reinforcement was reduced, 20% lower than today, and yes, it had some consequences. The detected problems were long along the history of the bridge. The bridge lived for about 50 years. 50 years is exactly the time that codes ensure in the main frame of the safety formats. So it accomplished the situation, although, as Juan said, it was too young to die. The bridge had movements in the longitudinal direction. Some cracks appear parallel to the longitudinal axis of the bridge. They were systematic. The bridge was on concrete. Maybe you think that it's steel, but no, it's concrete painted. Painter was here to jeopardize the situation. This is not a good strategy. Some seal cracks here in the past without diagnosis. If it is always easy to be critic with the engineers that were behind you beforehand, but it was very difficult to detect the problem. It would be unfair to say that it was a mistake of the past, but we have to learn the lessons of this situation. One Monday evening, Juan called me. I was in the school, I was teaching them, and he told me, we have discovered a crack 1 centimeter wide. I could not believe that, but on the following morning I went there and I could observe that indeed it had happened, that crack. This crack happened all of a sudden. This is important to say. We opened, we make a trial pit to discover the inside part of the tendon, and we observed that this tendon was broken. And in other positions, on the top part, we detected some incipient corrosions on the wires of some strands. After analyzing the history, after making visual inspection, as medical doctors do, we made analysis. Analysis and conclusions of the clinic history are the best basis to formulate a good diagnosis. This is very important for young people. We discovered that about 10% of the tendons could have corrosion problems. Some others would have been endangered by the lack of grouting, so those tendons were not protected against corrosion, and indeed they had collapsed. We took some samples of this tendon. I took it with my bike. I moved Madrid with bike. This is an example of sustainability. I went to the school and brought these samples to my colleagues in the lab. They analyzed the problem. They detected that the central wires of this strand behave in a tactile way. This is important. I will show you later on a diagram. But the outlying wires exhibited corrosion with less of a section and another type of corrosion. From the mechanical point of view, central wires behaved ductile, in a ductile way, but the outlying wires behaved with brittleness. This is very bad because they have severe consequences on the safety of the structure. Microphotographs of these wires showing the central one on the top part and the outlying wire on the bottom part with this typical inside cracks showing clearly corrosion, stress corrosion, leading to this brittle behavior. Another photograph, microphotograph, showing some the microstructure of the steel with some defaults here. You can think that it is typical of old steels. Steel was not as old, first, and second, today can happen the same. The consequences of brittleness is that the load-bearing capacity of the structure cannot be guaranteed. This is very, very important because if this is moments, overall loading, the design load is this one, but if due to cracking the redistribution of forces started in some way, and the structure is brittle, instead of having this ductile behavior, you could have this situation. So a brittle behavior with the certain sections incapable of redistribution moments can lead to a premature failure. So this corrosion was the most important concern of the team we were there. But it was not the only one. We analyzed also concrete, and we observed, with the help of Intemac, that the samples show systematically cracks in the gravel. The rubble was showing this type of cracks. You can see also here or here. It is very interesting because you see these stones are cracked in the same direction, but mortar in the middle is not broken. What was happening? It was a mystery. You see these white spots that were showing an alkali reaction. The reason why rubble was broken is that every element was submitted to the so-called Brazilian test. In this regard, you probably already know that on the central part of this specimen, you have tensile force, pure tensile force. On the top part, you have compression, and due to the difference of elastic modulus of mortar and stone, the mortar is compressed, like top part of the rubble, but the rest is broken. So concrete is not characterized by the characteristic strength. It's necessary to deepen into the analysis to analyze the microstructure or the mesostructure of the concrete. This is also a lesson to be learned. The design strength of concrete in 1968 was 400 kilos, 40 megapascals today. But the test carried out with samples taken from the bridge showed less than the half, 18 megapascals. Average value, less than 30. Elastic modulus, less or about half of the theoretical results. It was difficult. Much more important, a matter of much higher concern was the concrete properties, the endangered concrete properties, than the corrosion of steel. So the bridge of pre-stressed concrete was in severe danger. We opened, the quality of the pressure is not very good, but you can see here water coming. We opened a drill in the box to analyze if there was water inside. Yes, a lot of water. Dark water, very similar to Coke, to give you an idea. The Coke we drink. No, this was not possible to drink. We analyzed this water, and we came to the conclusion that was an accelerator of corrosion, because it was very bad for the structure. You can see here very clearly how this surrounding spot, white spots, showing the reaction between alkali and the aggregate. As mentioned, the load-bearing capacity was very endangered from the point of view of the load-bearing of the resistance. It was interesting because if the logical conclusion is that if a bridge has deflections, it's probably due that the elastic modulus is reduced. But the structure was perfectly aligned. Even you could still see the camber, the pre-camber that they probably provided during the construction. So the visual inspection and the experimental results became contradictory. Even more if you take into account that deflection is obtained according to this formula. You already know that. So deflection depends from the inverse of the elastic modulus. If the elastic modulus is divided by 2, deflection should be twice, double, but not. The bridge had not experimented deflections. Why? Because on the top part of this formula, you have Q, the load. But the load, the net load, which is the sum of the external load in self-weight, permanent loads, and so on, plus the loads induced by the deviation forces of the pre-stressing. This was almost zero, because in that time, by the end of the 60s, beginning of the 70s, even in Spain till the beginning of the 90s, the pre-stressing criteria was to provide to the structure as big as amount of pre-stressing to ensure that under the permanent loads or service loads even no tension appeared in any section. This is a consequence of the already mentioned excess of pre-stressing. To shorten my part of presentation, we analyzed the structure. We obtained very high values of stresses. The important thing is that the compression stress in concrete was higher than the 45% of the real value of the load-bearing capacity of concrete. It means that concrete was undergoing nonlinear creeping. So the formations were increasing a lot. So we analyzed the internal forces, we compare, we analyzed the safety factor, and we came to the conclusion that the situation was unacceptable. The bridge had completed his lifespan. The bridge was dying, and it was always a problem, a safety problem for users. So although it was a very interesting structure, although it was a piece of the heritage of Madrid, the bridge had no solution. Sad conclusion, but true conclusion. It was not possible to strengthen it. It was not possible since this is a normal situation for strengthening. You're strengthening not with zero loads, because the bridge was, or a structure is not possible to be free of charge, of loading, I mean. The real situation was here. So the additional capacity of concrete was almost zero. There was no margin to strengthening the bridge. After history, after analysis, diagnosis. Diagnosis is the conclusion. When you say what are the origin of the problems and what are the consequences. Well, I am going to be very quick with this. Avoid masking paint. This is very important to make a proper diagnosis, very important. It was a mistake in the past, it is easy to say. I would have made the same mistake. It's easy to say that if you see cracks, but the bridge seems to be in good condition, you paint, you avoid the criticism of other citizens regarding the cracking, and the bridge can continue. This is a mistake. You have to make a diagnosis, like medical doctors with you, exactly the same. Drain. It is a fact that the number of chemical attacks are increasing. Alkali, silica, alkali aggregate is quite frequent today, because although the problem started many years ago, 40, 30, 50 years ago, many problems today. It is important to know the knowledge of history is very important. If you analyze the construction type of a bridge, you can detect it belongs to a RICS group or not. Bridges erected till 1990, more or less, especially those with pre-stressing tendons produced till 1970, more or less, are especially submitted to this risk. This is important to bear in mind. And another conclusions that I will forgive.
So unfortunately, we had to dismantle this bridge, and then the Madrid City Council, our client, ordered us, Dragados, to dismantle or demolish it. Well, this work had a lot of conditions, boundary conditions. One of them, remember, it was an urban bridge in the middle of the city in a very busy area with a lot of streets. There are a lot of tunnels and galleries under the ground, which condition the demolition too, as we will see later. Of course, these works had to be done very quickly, because it's a very annoying work to work there in the middle of the city, so we had to do it as quick as possible and trying to minimize the annoyance for people, for the neighborhood traffic, etc., to reduce the production of noise and dust. We had an advantage. All this happened in the summer of 2020 during the COVID-19 pandemic, so the traffic had a very low level. It was the traffic was much lower than today than before. And as it was an emergency work, our client told us you had to demolish the bridge now, immediately. There was no design, no drawings, nothing. So we had to make, at the same time we demolished the bridge, we made not a design but action planning, a living document, which was more or less a design. This document was made by FECOR, by Javier León and his team. A very good work, by the way. And so we started to demolish the bridge. These pictures are not of this bridge. We had to choose, at the beginning, to choose the way to demolish the bridge. There are two kinds of demolition. The classical, traditional one, which consists in hit the bridge, cut the bridge, destroy the bridge. It is very quick, it's good sometimes. In the middle of nowhere, it's a good idea to do this, but we were in a city. It's not a very safe method if there are buildings near, for example, and the production of dust, the noise is very high, so we didn't choose this method. We prefer to do a surgical demolition with false work, cutting and dismantling. We will see what is this. Here we have some pictures of the demolition. Here we can see the bridge partially demolished. First of all, we put a false work behind the under the bridge, a big false work all over the lower part of the bridge, and then we cut the deck into pieces which remain supported by this false work, and then we took these pieces with trains to transport the pieces outside. Some details about this construction, or not construction. The false work which supported the bridge, it is similar to the one which probably was used 50 years before to erect the bridge. Then we cut the deck. We cut the deck by means of these machines with diamond wire, which is a good method, not very noisy, and which permits to cut the pieces of concrete. This is the plan of one of the spans of the bridge. These lines are the cutting lines, and those rectangles are the pieces. Those pieces were 3 meters wide. In this direction, most of the pieces were 3 meters wide. Why 3 meters? We will see it soon. After the deck is cut into pieces, two independent cranes take these pieces and then put them onto trailers, low bed trailers. Here we have a piece on the trailer, and on the right side we can see that the trailer takes the piece and goes out. Goes out to carry the piece to the facilities of a company specialized in processing construction and demolition waste. Why 3 meters wide? Because 3 meters is the limit between a normal transport and a special transport. Special transport means that the piece is very wide, so it's necessary to carry it to circulate through the city by night, at night, with escort, with the police. However, if they are normal transport, not very wide, the truck can go, and it's another vehicle. At any time of the day, they can go with pieces to carry out, with no police, not working at night, not making noise at night. Imagine if there's operations of the cranes taking the pieces, imagine them working at night, making noise at night. Why? No, it's better but during the day, not at night. So it's necessary to use normal transport, 3 meters wide. Very important to not increase the annoyance to people. Some aspects of the dismantling of the bridge. For example, imagine this work, as the bridge is around 400 meters long. This work is a big barrier for pedestrians. So we try to minimize this effect. How? Making these galleries crossing the false work in the middle of the bridge to let people cross to the other side of our work. Look at this. There are 2 galleries, one for each direction. Remember, we were in the COVID days, so pedestrians had to go through one side and come back through the other. Some weeks later, in the right side, you can see that we have demolished a part of the bridge, so we can put another pass. This you can see the. How much time do we have?
3 minutes.
3.
Yeah.
We have another pass, so we can demolish, eliminate this and demolish this span. Another thing, for example, we have a tunnel under the bridge here, and probably it couldn't resist the weight of the load of the bridge. So we had to make this kind of temporary bridge to take the load of the bridge through these temporary foundations to make no damage on the tunnel which was inside. When we started the demolition, we discovered that there were these ducts which are made of asbestos fiber cement, a very dangerous material. So we had to take a plan to cut these pieces, concrete pieces, trying to make as less dust as possible, and to process this part of concrete with asbestos inside. We wrapped these pieces with black plastic that we can see there in the picture, and then we moved them to a company which managed this dangerous waste. The last thing, trying to make trying to not to annoy, to make damage to the surrounding. The diamond wire and the tools to make holes in the concrete need water to refrigerate these elements. We can see here well, I don't know if we can see, but I can see here. The water falling down from the deck. This water is full of concrete. It's very dirty. We could throw this water to the sewage system. So we had to make these channels made of bricks and wood to carry the water to decantation basins like this, in which the solid part went down, and then the water was more or less clean, and we could pour it into the sewage system. Well, and what about date? We had to do this very quickly, and I think we did it, because we spent 103 days to make these operations, around 3 weeks less than planning. And we think that the neighborhood was not very angry with us, because they didn't make a lot of noise. Well, this is the aspect of the place in which 3 months before there was a breach. After, the Madrid City Council had to make another works to change the lanes, to enlarge the sidewalks, etc. But that's another story. Thank you very much.
Thank you very much for this extremely interesting insight. We have a few minutes from questions from the audience, if there's any. And if you would like to ask a question, please kindly introduce yourself and indicate to whom your question is addressed. So, any questions?
Yes. I have a question.
Okay, perfect. We have a question from one of the speakers.
A question for my dear Eduardo. I wonder if there was no other solution for the foundation. The foundation elements were very, very nice. They were pyramidal shaped. They take part of the heritage as well. And I wonder if there was no other solution than installing this pile cap covering the old foundation elements.
Thank you very much for the question, Javier, dear Javier. But I don't have the answer, I'm sorry. I know different solutions were analyzed. For example, a treatment of the ground and of the soil under the existing footings. But finally, I don't know why, because I'm not an expert in soil, in geotechnical aspects. My partners of Intermac decided that it was the best solution. Of course, we tried to use the first solution I mentioned, trusting in the bonding inside the existing footing, so that the existing footing will follow working in a different way, but working. But because of the new uses and new loads required for the new design, it was not possible to use that solution for all the market.
Other questions?
Okay. It has the red light, but it's the green light. Okay. I was surprised about the cost of the reinforcement solution about Legazpi market, and I wanted to ask how many square meters it has, and maybe the cost of this works is mainly cost because of the foundations. And my question also is, would it be possible to treat the soil somehow, maybe to work on the soil instead of the concrete structure. I mean, I think that it's very important to focus on the possibilities of reinforcement in concrete structures, and I understand that it is not a problem of the concrete. It's of course more a problem of the foundation and of the soil. So this way it can be seen other way. I don't know if you understand what I mean. The concrete structure was really good, in good conditions, although it's very old and maybe the maintenance was not good. But it is more a problem of the foundation. The cost of this, it was 100 million, 100 million euros.
Yeah, that's right.
What part of it was cost because of this intervention in the foundation is the question, and if there were other possibilities about the soil treatment maybe. Thank you.
As I mentioned, thank you very much for your question. As I mentioned in the presentation, the cost of the actions in the foundations were about 15 million euros, which is huge, but there are still 85 million euros for the rest of the actions, and most of them are for architectural and the new installations and other things. I'm not in that part of the project, and I can tell you about that. Regarding the solution for the foundations, all I can tell you is what I just told Javier, and it was decided that it was the best solution. I don't know if I've completely answered.
Does the market have the meters? Just
it is about 30,000 meters of the building. The site is quite bigger, and for example, in the new restoration, inside the central square, there will be 2 more floors.
So we will go for the last question to avoid having a big.
Thank you so much for the presentation. It was really interesting to see a death of a bridge, which is a very new concept. I had 2 questions. Maybe it's more of a curiosity rather than a questioning. I want to ask, when you made the plan for demolition, you made it into 3 meters pieces for the transport. So the first question is, were those pieces usable post the production for some non-structural purpose or something? Were they used for something? And the second question is, what about the foundation that was there for the bridge? Were they demolished, or are they still in place because it's substructure pieces?
The concrete was severely attacked by silica alkali, so the concrete was not reusable. Aggregates were severely damaged, so all the elements were sent to a treatment plant. 3 meters wide sections were transported to this plant, and steel was recycled, both mild and pre-stressing steel. But concrete, unfortunately, was not able to new applications in structural concrete. For other applications, probably, but not for structural ones. And the other question?
About the foundation.
The foundation. The foundation.
Yes, the foundations are there still. Are still there. They are spread foundations, not piles, but they are. You can find them.
Will it be an issue if we create some plans in the future, maybe for a new bridge, maybe for the roads?
No. There is no bridge, no new bridge.
Okay.
Now it's the street is on the ground, and well, I don't know.
Neighbors are very happy with the situation nowadays, because they have free space, no structure in front of them, less noise. People can walk, people can use the bicycle. It was not the situation beforehand. So it's a matter of fashion. In that time, the 60s, 70s, all the structures were oriented in favor for traffic, but nowadays the situation is quite different.
Yes, however, if 55 years ago it was necessary a bridge, imagine today. But, well, drivers go trying to avoid this area for another streets.
Yes. Thank you so much.
Welcome.
So thank you so much again to our speakers. And now we invite you to enjoy a coffee break, generously supported by Arespa, Officemen, IECA, and EHOP. You can also are welcome to visit the exhibition area featuring contribution from several collaborating companies of the Concreto project, and we restart in about 20 minutes at 12.
3.
So, welcome back. And we are now beginning the second part of today's program. And this is my pleasure to introduce Carlos Polimón. Carlos is a structural engineer by vocation. His career includes the design and construction of bridges, civil works in refineries, caissons and outflow structures in Spanish ports, and offshore meteorological towers in the North Sea. He is currently Director of Engineering at Retineo Ingeniería, focusing on structural repair and rehabilitation. Committed to promoting the value of the profession, he chairs the Structures and Society Commission at the Spanish Association for Structural Engineering and serves as the Advisory Council of the Juan Eloy Turriano Foundation. Today, Carlos will speak us about the effectiveness of inhibitors for comprehensive corrosion control. So, Carlos, thank you.
Thank you very much. ¿El otro? Now? Better? Okay. Thank you very much. I'm Carlos Polimón. I am the Director of Engineering of Retineo, as he said. Retineo is a construction company specialized in reparation and restoration of structures. Specifically, where we add more value is in concrete and masonry structures. When I was invited to this event, I decided to bring to you this presentation of this work because I think it has a didactic issue that can be good for all of you, and that perhaps if I want you to take one idea, is more or less the title of the presentation, is that when we do a work of reparation, we have to control the effectiveness of the work. Okay, so this case is important because all the stakeholders of the work, we were all aligned in the prosecution of the same aim, is not to repair again if possible. Okay, we have to think that when we have a client that call us, the client has a problem. He has already a problem. He has a structural damage, and his desire is not to repair again. So we have a great responsibility in what we do, and of course the way we do it. Okay. Let's introduce the client. The client is el Hotel Club La Santa. La Santa is the village in Lanzarote, Canary Island, Spain, close to the hotel, and gives the name to the installation. This is a project that lasted for 1 year, more or less, from the beginning on the inspection to the completing of the works. Okay, it was a very fast project because the client was very interested in solving it in a short period, because at the beginning of the works it was the COVID pandemic, so the installation were closed. So it was a great opportunity for them to not losing time and money with other clients for the hotel. Okay. It was a turnkey project. It means that we made the first inspection of the pathology and the structure. We developed the project of the reparation, and we worked on site, doing also the managing direction of our project management on site. As I will say now, the client loves what they do, and this is the most important point, or the key point, when you have a reparation, because it means that they are in this position of contracting people like Carmen Andrade, the following speaker, and Jesus Rodriguez Santiago, as a structural specialist, because they wanted to have the best solution for their problems. Okay. I don't know. No. Sorry. It's my fault. I don't know if there's... Okay. Well, there is the location of Lanzarote. If you all, I guess you more or less know Canary Island. Lanzarote is the island which is more to the north of... and it means that waves and wind goes directly to the east, to the west side of the island, okay, and it's almost like a paradise, but it's a volcanic island, so it means that if they wouldn't have the wind, it would be a hard place to be, and as we will see later, it is more or less important when you are working with products like mortars and concrete. Well, this is the complete facilities of the hotel. The hotel is completely focused on sports. Okay, it's a place that if you love sport, I recommend to go at least once because you can practice every sport you want. You can see there tennis and paddle courts, athletics tracks, swimming pools, Olympic swimming pools, every kind of sport you want to practice there. You will have fun and be in a good place. And in addition, they house the Ironman of Lanzarote. I don't know if you are familiarized with this kind of sport. They house the Lanzarote Ironman, and it's one of the most known events for this kind of sport in the world. And it's very hard, in fact. So our work was directed to the swimming pool, to this mark in yellow, to Olympic swimming pools, because after they completed the construction of the swimming pools and the gallery beneath, the galleries are where all the energy for the hotel goes from there. This is the core, let's say, of the energy of all the hotel, and they have more than 2 kilometers of galleries from that point to the rest of the hotel. Then when they completed the original construction of the swimming pools, in a short period of time they began to have quite a lot of problems with leaking. Okay, so we will see now. I have brought you this video. Let me play this video. It's very short, just to let you imagine and know the place where we work it. Because when we say galleries of conducts, we can think that they're not very big, but these are the central one. I don't know if this works. Yes. Is this one in the center of the two swimming pools. And no sé cómo será esto ahora. Para el vídeo. Oh, okay. Thank you. So this is the central gallery between the two swimming pools. You can see the state of the concrete. It had a lot of leaks, a lot of leaking, as I was saying. And these are the pumps and all for the swimming pools and for all the hotel. As I say, these very big galleries, but they are full of conduits, pipes, and services. This is the lateral gallery, and all of the water of the swimming pool, because a lack of waterproofing, was leaking through the concrete. Okay. So I think with this you can have a more precise idea of the site of work. Let's go to the first phase. As I said, it is the inspection and the pathology report of the structure. This is a very critical phase of the project because it's where you have to define the causes and the consequences of the damage in your structure. Then every crack were measured and were drawn. So you can see there are quite a lot of red cracks in the drawing, and this work is so important because you can localize where the cracks are. Then we can see that they are not in the whole height of the walls, they are just in one of the faces of the concrete. Okay, so that's why this visual inspection initially is so important. We did a structural assessment too, because, well, it's a swimming pool. We can think that it's not a structure where the loads are very high, just with the geometry of the walls for making the reinforcement of steel, you will have stiffness enough to support that loads. But you have to do all the calculation with the actual properties of the material. So in the best case, in this kind of works, you will have an as-built report, but sometimes you don't. So you cannot trust only the drawings of the original project, and you have to check and assess that the structural behavior is proper to the loads. Okay, so we made some calculation. Later during the work, we made much more calculation to be sure that everything was going to behave properly. And it's an important way of being sure that you are working in a structure that is safe. Okay. I have brought to you to the kind of testing we usually do in this kind of projects. I don't know if you know the test that we can perform, or construction companies can perform. The first of all is the sclerometer. It's like a hammer. It's a hammer that is used to know the strength of the concrete. It's a non-destructive test, and that's the good point. The bad point is that it's very influenced with how the surface of the concrete is. So if you have carbonation or you have cracks in the surface, can be not very accurate. Okay, but we use it as a contract test with boreholes or concrete samples, as we will see. We perform too the steel Brinell hardness. This is an accurate method. To be honest, nowadays, if the structure is not very old, the steel is very well known, and the process of fabrication of the steel is so accurate that you can be sure that the yield strength is what is in the drawings. Okay, but it's another way of contrasting, and it's an important test if you have a structure with not so old age. And the concrete carbonation. The concrete carbonation is one of the two ways of corrosion of the reinforcement. It affects in all the surface of the concrete, and what happens is that the pH of the concrete lowers down, and it initially is basic, and that's why it protects the reinforcement, and the carbonation makes that pH lower and leave the reinforcement unprotected. Okay. In that figure, you can see in blue is the cover of the bars, and in red is in every point the carbonation we had. I have to say that the structure was 8 years old and the carbonation was very advanced. Okay, so in this kind of process, you can know how long will take the carbonation to get into the bars. Okay, and we calculated it, and it was more or less another 8 years, and the pH of the concrete was not high enough to protect the bars. Okay. As I was saying, the sclerometer is not a very accurate sometimes testing. So what is more interesting to do, if you can do destructive test, is to have some test samples with boreholes, so you can just break them and know the compression strength of a concrete. Okay, there you can see the carbonation advance in the samples. Where we have purple color is that the pH is still basic and is protecting the rebars. Where is just gray at the beginning is the thickness that is not protecting. The pH has lowered and is not protecting anymore. Okay. This is another test we are able to develop. It has a name a bit difficult, the X-ray fluorescence spectrometry. This is a tool we developed in a research project with Torroja Institute in Madrid, and it's able to check the chlorides in the concrete. And it's very fast because we only have to make a drill in the concrete and just take the dust, the powder, and check it with this tool. So if you have a cover in the rebars, for example, of 5 centimeters, we can drill at 2 centimeters, 4 centimeters, 6 centimeters, and have the curve of the penetration of the chlorides. Okay. And the last one is the corrosion risk rate. This is a tool called GECOR 10, in Spanish GECOR 10, and it's used because it combines the measurement of the potential and the resistivity in the bars in a very concentrated place, 1 or 2 rebars much, and gives you very fast to the rate of corrosion that you have in the place where you test. Okay, this is a figure where you can see the initial value of the corrosion rate in blue. Okay, I translate to you because I don't have it in English. Up to 0.1, sorry, is a low corrosion rate. To 1 is moderated, high, very high, up to 100. Okay, so initially we had values all of a high corrosion rate. Then in these works, what we did the first month is to apply an inhibitor, a migrant inhibitor for corrosion, and wait for the 5-6 weeks it takes to work and to lower down. That's what you find, you want to lower down the corrosion rate. So after that 5 or 6 weeks, you can see in orange that it was all lowered. So we saw all of these works were directed by Carmen. We saw that the effectiveness of the product was correct. Okay, so here we have the conclusions of this first step. First of all, high vertical cracking due to the lack of contraction and expansion joint. Okay, the swimming pool is 50 meters long and it's, I think, 22.5 wide. So it didn't have any expansion or contraction joints in all the length. Sorry. So the problem is that when the concrete was curing, it cracked by itself. So that initial visual inspection, as I said, gave us the idea that there was the problem. There weren't any joint. The concrete strength had a reduction between 30 and 50%. It meant that when we did all the assessment of the structure, if initially the concrete was supposed to have 30 megapascal, it had more or less than 15 in some points. So that's why you have to test the concrete you have, because perhaps the concrete is not behaving as you think. The concrete permeability was over the threshold of the standard. As it was, the chlorides more or less of the half of the samples for the chlorides. Okay. There was a significant carbonation in the early ages, as I was saying. It was more or less another 8 years to be unprotected, the bars. And perhaps the most important issue was the fail of the impermeabilization in the beaches of the swimming pools and in the protection of the walls of the swimming pool. But the good news was that the structural behavior was correct, except for some concentrated points in the slabs over some pillars. Okay. Second step was the project. These are the figures of the work. We applied 3,400, more or less 60 square meters of migrant corrosion inhibitor. Almost 2 kilometers of cracks were sealed. 600 meters of high palon band is to protect or to cover, is used to cover the 2 phases of concrete, okay, construction joints. Was the liner of the swimming pool was completely removed and reinstalled, new one, and sealing of pipes and conduct, and the installation of a waterproof pavement. Okay, so this is just 2 views of the project, because when the clients with swimming pools or dams or works structures with water have just some panic, okay? And they let you know that they have some panic, so you have to, because they don't want to have leaks anymore. And in a swimming pool, for example, or in a dam, it's very, very difficult not to have new leaks in some point, okay? We are talking about a huge surface of water. So what we decided to do was to use redundant solutions for all the impermeabilization. So if we see here, I don't know what is here, in the walls of, these are the water side, we had a waterproof mortar, liner, and that liner goes all around this piece, this element goes beneath the pavement. There on the top you have another waterproofing mortar. Here you have a high palon band for the sealing the joints. So everything was redundant, okay? So the problem was to do a correct installation of all the elements, not to have leaks in the future. This is a spoiler of the finishing of the works, but I wanted to talk about it in the project, in this step, because it was the most important point of the works, okay? And it's more or less the title of the presentation, the importance of measuring, okay? You have to think that we perform thousands of measures of the effectiveness of the inhibitor, because as I said before, you have to wait 5-6 weeks to be sure that the inhibitor is doing its work. So for us, it was very important to be sure, and for the client, it was very important to be really sure that it was working, because if you don't check it, you just apply it, and if you don't wait and you cover it, normally you cover with a carbonation painting or a mortar, waterproof mortar, you won't be able later to be sure that the inhibitor is working properly. So, although it was a hard point for us, because we have to wait in every wall 5 or 6 weeks to be sure that we can continue with the works, with the mortar, it was done in every point we worked it. And this was Carmen's idea. I say it in this point of the project because it was not a decision that my company did. She did with Jesus, both. And, well, it was so important that after some years, we will see it now, the points lowered completely the corrosion rate that it was the aim of the work. This is a migrant corrosion inhibitor. How it's the application, as you can see, is a transparent liquid, and it's the application is as easy as that. Okay, you only have to spread it in the surface of the concrete, and it goes inside the voids due to the porosity of the concrete by capillarity, and it goes to up to the rebars, and it lowers their corrosion rate. And it's very fast, the application, and it's very easy. What is not so easy is, as I said, to wait all that weeks to complete the work in every wall. Okay? But in this project, we did it in all of the points, as I said, with the G-Core 10, G-Core 10, and that is that device on the right. And so once we checked that the inhibitor was working properly, we completed the work. If not, we had to wait and be sure some days, some weeks later that it worked. So as you can imagine, this for a work site is a bit difficult, okay? And this is some data of months ago, more or less, I think. This the new ones, the new.
After the application of the.
No, this is this year. The results 3 years later, okay. And as you can see, in red is the limit, the threshold.
No, they were your data after the application.
No, the first one. This is another one. This is the last report. This is the how 3 years later the inhibitor worked correctly, and the corrosion rate is still under 0.2. That was the threshold established. No sé cómo voy, ¿cómo dices? ¿Ya? Okay. Then, yeah. Sorry. Well, the conclusion is that in every reparation, you have, if possible, to be sure that the products, that there are high quality products, but you have to be sure that the application and the effectiveness is correct. If not, you think that you are doing a good reparation, and in a short period of time you will have problems again. So thank you very much for your attention, and that's all.
Thank you, Carlos. And now we move. If we have any questions, okay, we are going as before, and we will make them all together after Carmen's presentation. And we move to our final technical presentation of the day by a true pioneer in the field, Carmen Andrade. Carmen holds a PhD in industrial chemistry and honorary doctorates from the University of Trondheim and Alicante. In 2021, she held the Construindo Amanhã chair at the University of Sao Paulo. Long-serving research professor at the Institute of Construction Sciences, she is now a senior distinguished researcher at the International Center of Numerical Methods in Engineering. Her work has been key in advancing knowledge on reinforced corrosion, monitoring techniques, and concrete durability. She has led organizations such as the International Union of Laboratories and Experts in Construction Materials, Systems and Structures, the European Union of Agreements, the World Federation of Technical Assessment Organization, and the Ibero-American Association for Concrete Rehabilitation. In 2024, she received the FIBA Medal of Merit. She will now speak to us about corrosion monitoring in concrete structures. So, Carmen, the floor is on you.
Thank you. Well, many thanks to the organizers and congratulations for this very interesting project. I think that is very good for the young people, and I found your description very interesting. And also many thanks to Professor Todisco for the invitation. I am going today to talk about the monitoring, and this is my content today. I will talk about motivation, purpose of monitoring, the need of calibration, the type of processes and techniques, and some case studies. And I am not going to go in details. That is really sometimes I noticed that is sometimes a challenge to all about the transmission, the data management, and so on, because you need energy, but these details I am not going to deal with. If you are interested, we can comment on there. About the motivation. Now there is like an enthusiasm for monitoring, and just with the digitalization, all people think that they need to do something, and the easiest manner to say digitalization is, yes, I place a sensor. But it's very important to think, and to think first why to monitor. I mean, like when you design a new infrastructure, I have always listened to the designers that you need to have first the concept of the infrastructure. You need to think first, not just to start to do the things. And I think that this is very important. I would like to emphasize for you, the young people, on that, because otherwise you may frustrate very much the owner if you don't have clearly the objectives for the monitoring. And this is what I am going to repeat several times. And also when and how long, because maybe you don't need to say monitoring for the whole life. Maybe 1 year or some time is enough. In that case, it's very important to answer these points before. And the first step in a monitoring is to identify the objective, why you are monitoring. And as I said, is to avoid the frustration, because there are several or many installations, like happened with the cathodic protection, that after some months that are there without any surveillance, and this is really a problem for the future if we like to extend this. And to define the objectives, you may have several. I identified 4 main here. One can be to detect corrosion, at the onset of corrosion. That is going into the service life simple model that was proposed by Tuuti for talking about, in general, degradation. You have, and this is for corrosion, but in degradation is always the same. You have here an initiation period until the damage is starting, and after you start to grow the damage, maybe cracking, corrosion, whatever, until a certain degree that you establish as limit state. In that case, you may like in a new structure, a non-corroding structure, to detect simply when it's starting to corrosion. That is correct. But you need to define, because after you may try to have other consequences, and if you have not foreseen from the beginning, maybe you are not able to collect. The second is to relate the corrosion data with other parameters, for instance, with the mechanical performance. In that case, also, you need to foresee previously that this is the aim of your data. I will show later on. Also, to predict the future evolution, just to make the prediction when you are going to reach a limit state. In that case, for example, you may like to calculate the service life, the time. In that case, you need the model, integration of the data management with certain models, and also now is the fashion is to have the digital twin. In that case, all this maybe that you need some information that you need to foresee from the beginning. As a fourth objective, and I think that for me has been very important, is simply to learn how the structural performance is, how corrosion is developing with a level of detail that with periodic measurements you don't have. In that case, for the researchers, it's very important to learn and to learn the performance in real conditions. The parameters and technique that when you mix them, you have the sensors, the known sensors, what we can monitor related to degradation. Well, it has been already mentioned, the need to have electrochemical techniques and electrochemical sensors for potential, for resistivity and corrosion rate. And why is so important? I say there are several techniques to measure different parameters, but the most important for corrosion is electrochemical techniques. It's because the corrosion is an electrochemical process. In that case, all the other type of techniques are indirect measurement. Only if you have an electrochemical technique that is just in the same mechanism than your process is when you are able to derive the best result. In that case, I say that because it has been tried to measure corrosion through acoustic emission, through ultrasounds, through magnetic fields, and so on. And these are not electrochemical. In that case, they are sure, they are informing, but they will have empirical relations with the corrosion. The only techniques that have a direct basement in the corrosion are the electrochemical ones, and are these three ones. After, you can measure physical aspect like temperature, moisture, and there you can measure the relative humidity in the air or the liquid water, that is the retained water in the pores. Chemical, like pH or carbonation or the chlorides, and of course mechanical, because all degradation is going to produce cracking and you may need to have this information. And from this, as I said, the most crucial is the corrosion rate. I will show, and all the other are complementary and indirect techniques on there. But whatever is the sensor, you need to calibrate. The sensors, even those of corrosion rate, they are very critical to be calibrated, and you need to anticipate that you are going to manage a huge file, and therefore the sequence, how often you are going to collect the data is critical, because after you realize that there are a lot of data that are not needed, because if you delay the moment of measurement, you have much better information and you have less amount of data. Okay, there are bibliography in this area. There are island recommendations. In 2000, we were publishing about the measurement of resistivity in concrete. In 2003, for the half-cell potential and potential mapping. 2004, for the corrosion rate measurements. And finally, through Venezuelan, we were publishing a recommendation on embedded probes. And in Spanish, through Alcompat, the Latin American Association for Rehabilitation, we have these recommendations in Spanish. Well, the electrochemical techniques, and here a bit of education, is short, after I will go through the cases that are much better, but a bit of education for you. And these are the three techniques I was mentioning: the corrosion potential, simply with a reference electrode that has a potential that is fixed. You measure the potential of the bar, and you can distinguish whether it's corroding or not. Because this has a fixed potential, always you can have the difference. It's like the temperature. You can measure with a thermometer. Here we measure with this reference potential through a voltmeter or a multimeter. We have also the resistivity. Both are qualitative, and this is informing on the amount of water, the degree of saturation of the concrete. That is indirectly related to the corrosion. And you have the possibility, Carlos has already mentioned and shown, the possibility to measure the corrosion rate. What is the corrosion rate? The corrosion rate gives you the slope of this. I mean, gives you the rate of the corrosion of the steel. In that case, is the slope of this diagram, and that is why it's crucial. It's the only one that is able that you can predict ahead or you can predict back where the corrosion has started. But only if you measure a rate, that rate is the change of a property in time, is when you are able to predict or to introduce the result in a model. Well, on reference electrodes, very quickly, there are several reference electrodes that you can embed in the concrete. For the potential, the manganese that is the most stable, copper sulfate or silver chloride. And each of them have a different reference value, and we have the ranges to just conclude whether the corrosion is low, medium, or high, but that is qualitative, and they are attached to the bars, usually. For the corrosion, other type, I have summarized, for the temperature is a typical platinum or a thermopar. A thermopar. For the humidity, it's necessary to distinguish the humidity in the air, that is relative humidity, than the liquid water. For the liquid water, we have a small piece of gypsum that has two bars inside, two metals that are different, and when they have we have water there, there is a difference in potential or a current circulating, vibrating gauges for the mechanical to measure expansion. For the resistivity, we may have a 2 bars or a 4 bar sensor. And for the corrosion rate, we have different type of sensors with different geometries on there. And we may produce integrated systems. In this moment, there are several companies commercializing these sensors, and for me the problem is that you need to calibrate them. Why? I will say in the next one why it's necessary to calibrate. Well, the technique that is used for the corrosion rate is called polarization resistance technique, and is like the Ohm's law, that is potential, resistance, and current. I apply a small current to the bar through an external device, that is this one, and if I measure the relation between the potential and the current, I have a resistance. Is the resistance to the corrosion. It's called polarization resistance or corrosion resistance, and it's inverse with the corrosion rate. The corrosion rate is a constant that for concrete is 26 millivolts divided by the polarization resistance that I measure here. But, and this is the key point, you need to multiply by the area, because if you don't know in which area you have the amperes or the volts, you cannot standardize the value. You need to define the area. In that case, you can multiply here, or you can divide the corrosion that you obtain, the amperes you obtain, you can divide after by the area. And as Carlos has shown, there are several values. We have ranked them. They are in the Ryland recommendation, and you can plot them, and you know that some of them are passive because are below this value, or are corroding, or are very highly corroding. And this comes from the extrapolation to 100 years in the Tuutis diagram of these values, and whether the loss in the diameter is negligible, is low, moderate, thinking always in the 100 years age. But what happened in the real structures? In the real structure is that when you apply a current, you need a small counter, and the current is not confined there, is spraying, is vanishing along the bar, because the bar is much larger. In that case, we lack of a precise area. And this is the key point with the commercial techniques. You need to be sure that they are able to account for the area. Otherwise, is not correct, the measurement. They have errors. And how we have made, and we patented, Geocisa has patented in 1990, and now, well, I will say that later, and we patented several methods to measure that. This is coming from failure work in one of my master in corrosion. One is to measure how long this current goes. In that case, you can place several reference electrodes besides the counter and the central electrode, and you measure how long the current goes. In that case, you can have the total area that is affected. That is we call attenuation of potential method. And the other is to confine, that is what is in GCOR 10 now, to confine the current through a guard ring. That is like it's a Faraday's cage. You applied a counter field electrode, electrical field electrode, and you confine. And in order to be sure that you are below this part, you need to have some additional reference electrodes there to be sure that you control there. And again, this is a key point. There are commercial devices that are either not confining or they are not confining correctly. And this is measuring in several places. This is how the probe looks like with the central counter, the guard ring, and the reference electrodes there. And you need always to account how much steel bar you have below this circle that is between these two discs there. And this is a correct confinement, but if you don't have confinement, the current may go in this manner. And the other constraint, the main constraint, is that you need to wait a time, because when you apply the current, there is a transitory period, and that is lasting about 30 seconds. If you have a technique that says that measure before 30 seconds, they are going to give erroneous results because they are in what is called the transitory period. You need to go until the signal is constant and you are in a steady state condition. Okay. The other difficulty is that the corrosion rate changes with the weather and with the moisture condition. In that case, we have collected data now almost 30 years in which we measure along the year, and we detect the seasonal changes of temperature and humidity, the raining periods, and there are changes, and how to manage this. Then you need to integrate the area below each time, and you obtain an increase in the loss of section or the loss of diameter that is similar to that of foreseen by Tutti. That is almost linear, the increase of the depth of corrosion with time. I have no time to say too much about that, but that is very critical. It's not only the corrosion rate what is important, but also the collection in time when you need to record. And we have installed also in holes relative humidity and temperature probes, because this is a complementary information that is very interesting to interpret these changes there. Case studies now is less there and more. I will talk about measurement of internal moisture for a bridge deck, the racehorse of La Zarzuela from Torroja, and the roofs of the Prado Museum. Well, in order to show this is a bridge that within a project, a Spanish project, the Ministry of Transport, they were interested because they found that between the asphalt layer and the concrete deck, they had a lot of degradation, and they lacked to have what is happening there. In that case, we proposed to measure the moisture at different distances from the asphalt layer. In that case, we drilled several cores and we placed a humidity and temperature sensor there at different distances. Here, the objective was clearly identified, the accumulation of the icing source below the asphalt layer. And this is how this was, because this hanging the wires, and these were the humidity probes, and also we installed an external weather or atmospheric station. And these are the results in this case. This in green here is the closest to the asphalt, this is the other, and this is the other. This is 100% relative humidity, and here is 0% relative humidity. This is the external change, as I said, the seasonal change in temperature and humidity. But look, it's fully saturated near the asphalt. Well, you know, in Spain they are starting to use some impermeabilization layers between the asphalt and the concrete now. But even in this is summer, that was completely saturated, winter less saturation, and summer again completely saturated. We needed only 1 year for this. And what happened there in this case? We interpreted that we have in winter, with lower temperature, we have the condensation, because there is not breathing in the upper part. In that case is condensation. And it's clear that the possibility to dry is closest to the lower part that has not the asphalt. Okay, the racehorse arena La Zarzuela, you know that is from Eduardo Torroja. It has been already presented. This was in a dinner that we have there with 80th anniversary of the Institute Torroja. It's very nice when they have the illumination. And well, it was repaired, was built in 1941, although part of it was already before the war, and it received several bombs. There are holes there. And well, this is Torroja during the construction. There are two different photographies, but is him in there. We have several of him during the construction. And in 2008, there have been several rehabilitation, but the major one has been started in 2008. And we were asked to make an assessment, and we detected that there is corrosion of the reinforcement by carbonation. Much less than we were thinking, but what they found was Leonardo Fernández Troyano and Junqueras as architects. They were the designers of the rehabilitation, and they found a lot of shrinkage cracking, a lot of cracks, and really they tried to obtain again the monolithism in the shell, and there was a lot of injection of the cracks. Well, we were dealing with the corrosion. Here we did first a survey with the corrosion rate meter, and we were measuring the corrosion rate in all these parts, and just we apply, I said, the different levels of corrosion by the corrosion rate. But we also installed some sensors there in the different, in the three modules. We installed several sensors. They were sensors of temperature, the potential, and also the liquid water and the resistivity and corrosion potential, an integrated one. With a system very, very simple, you need to collect there the data. Well, there are several results that we don't have time to comment, but the people in the Institute now, I assume they maybe continue recording and analyzing the results. On the Prado Museum, this is not exactly concrete, but I thought that could be interesting for you because it's the Prado Museum. We were really fascinated with the case. There was a leaking. They changed the roofs, and they recovered the roof in lead. Instead of tiles, they substitute by the original roof. The original roof in Prado Museum was in lead, but this was removed during the Napoleon War, and they did for the guns, they did, ¿cómo se dice las balas? Projectiles over there. In that case, they put tiles, and in this rehabilitation, they try to recover. The problem is that there are a lot of details, small details, and it appeared that was a big leaking in the room where the Meninas was exhibited. In that case, we were immediately asked by the Ministry of Education at that moment, that culture was depending on him, it was Mariano Rajoy, after was president, and he was asking the institute to make an assessment and what. There was a group of architects and engineers just looking with to the roof and to the type of problem, but in our case that we were durability, we were convincing the ministry to install several sensors in the different layers of the roof, because this was a new roof with different layers, and we were thinking that maybe they are leaking in some of them. In that case, we installed these sensors to detect that of the liquid water when you have a jump is because there is a connection between the galvanic couple inside the gypsum, and in that case you detect when they are in active corrosion. And here, for instance, was the recording when they installed a good impermeabilization, the signal was completely different. We were able to detect raining events sometimes in different places of the roof. And here also we were collecting the temperature, and look in winter, in January, and in summer, in August, the big differences in order they could calculate the differences that they have, and also with the spatial distribution. These are some examples that you can after handle and manage the data in order to derive a lot of more of information on there. And here is the comparison between the external, the ambient humidity, and the internal humidity. And I am finishing. This was the case of, to detect the passivation. I will go quickly. These are caissons. And this is the Prado, also El Pedrido, that is also from Torroja, where we install corrosion rate in order to know the performance after repairing. And another bridge in Seville, and I would like to finish with this. From the resistivity, we were able to predict in this Langostera bridge the time to corrosion there, and I would like to finish with this, that is our oldest, or my oldest case in El Cabril en Resa, where the radioactive waste are being buried there. And here for the radioactive waste storage, they use big containers in concrete, 30 by 30 meters, that inside they have small containers where the drums with the radioactive waste are introduced. They put this in the different hospitals or so, they treat, and after they introduce here. And they like to have how it will be the performance of this concrete that is buried. Is the only case that I know that has been studied, the corrosion in buried conditions, because they like to know what may happen during the 300 years that this is going to be working. Well, we instrumented one container, and we installed besides the container that is buried there, we installed the measurement of the sensors. And this is what happened. It's very important, the temperature. You look all the seasonal changes, they are important. They depend on this is 2 meters, not too much, but is detected by the difference in there. I am finishing. And these are resistivity and temperature, that resistivity versus temperature, in order to have the activation energy that is very important for predicting climatic change, if so, because if temperature is going to change, we need to know how the different properties change with temperature, and you see that in upper part and lower part is completely different. And the data treatment to make average values that is an Arrhenius plot with the activation energy. Key point, activation energy is not the same, is evolving with time, and also is changing from some parts of upper part and lower part. In that case, to predict based in Arrhenius law is very uncertain, because we don't know the precise activation energy. To finish, to define clearly objectives when you are going to monitor, calibrate the sensors with external either humidity, corrosion rate with the corrosion rate meter, and we need to learn much more to be able to predict the effect of climate and climate change. And this is my last message for you, the young people. We have models for the ambient. We know that the water content is critical, but we don't have the function to predict the amount of water inside the concrete from the climate. Any publication saying that they are going to predict the behavior, if they don't have this function, they cannot predict. And if we increase the water, we are detecting in Spain, we dry the concrete, and that means less degradation and not more corrosion. And this is my last message for you. To predict the climatic change is important, it's a challenge, but we need to make it rigorously. Otherwise, we are, and I say that because there is a joint research center document that is not taking into account that function. In that case, is a pity because you need to be very rigorous for just predicting more corrosion if you are going to have higher temperature. Okay, thank you very much.
Thank you very much, Carmen. Now we have a few minutes for some questions, if any, in the audience. Do you have any question for our speakers? There's one question.
I've got a quick question for Carmen. We can do, for instance, cathodic protection for reinforcements, right? So instead of relying on these prediction models, can we somehow design the structures where we can have like probes that are sticking out of the concrete that are connected to the reinforcement bars for future, let's say, testing, like instead of relying on predictive models? Do you get what I mean?
Rely on?
Relying on predictive methods on like what the corrosion level is inside. Can we, for instance, have, when we design the structure, we can create like probes that are coming out of the concrete, out of the concrete that are connected to the rebars, which could be used in like the next 10 years, 15 years to test for these. You get what I mean? Like a very cheap solution, but because in the future we will have the problem, right? So can we design it in a way that helps us?
Well, I hope to have understood you. There, I see 2 points in your. Yes, if you can monitor from the beginning, but in that case you need to be clear for the owner that you are going to learn. In that case, it's collecting data, to be very patient, because maybe in 50 years they get nothing, because if the corrosion is not starting after 40 or 50 years that is expected, they collect nothing. And in that case, maybe the technology for the sensors and for the measurement has improved. In that case, just well, in this El Cabril is 30 years now, and the techniques are still there and the sensors are there. But we didn't know when we started how long they are going to last, the embedded sensors. One is one point, thinking that maybe in 10 years the technologies have improved a lot on there. The second point, the ability of the models for predicting. The present models we have for predicting are very uncertain, but the main point is because we are uncertain on the climate. If we don't know the climate, we don't know how much chlorides will be there, that you are putting the ice in salt, but maybe the next year you are adding less. Or we don't have this good connection between the action and the effect of the action. In that case, we have a lot of uncertainty. But in spite of the uncertainty of the models we need to use, because this is the only manner to calibrate them. We need to start to have the error of the models for prediction. And if you don't use, you cannot have the error. You need to use, but being aware on the uncertainty. And for me, the main uncertainty is the relation between the climate and the internal condition.
Okay, I understand. Thank you.
Another question?
Thank you again. It's a pleasure to hear you, Carmen, because during my PhD and my work in the university, I always cited your work, so I'm happy to be here. I come from the University of Las Palmas. I have one question because I've been working all my life with pozzolanic cements, and I understand that some of the problems you found in La Santa maybe are caused because of the pozzolanic activity, because the cement you're working with has low portlandite. So maybe it's normal that you find a low pH when you are working with these cements. But this is not the point. The question I have is, when you use these inhibitors, the first question is, which one is and why you decided to use that inhibitor? Because you didn't mention, maybe because the chemical is very complicated, but if you can tell me which one it was. And also you told that you need 5-6 weeks to monitor and to know if it is working properly. Is there any other possibility just to have some drills, and the same way you drill and you take for example, the chloride, you said with the spectrum you could do it, maybe also with the inhibitor is it possible, and you don't have to wait so long time, and also maybe it can give you an answer if it is spread properly, and if it is there any decision about the type of cement you use and the inhibitor you use. I mean, the compatibility between them. Is it studied before you decided, or you just use it because you understood that that kind of inhibitor was right? Thank you.
Yo empiezo con el primero. Well, about the pozzolanic activity, pH is different than the portlandite. I mean, you may have a pozzolanic material that is giving a high pH because it has alkalis. The pH in the concrete is not fixed only by the portlandite, by the sodium and potassium as well. And they may have high amount. In that case, it's not the pH. The pozzolanic is less portlandite. In that case, the carbonation is easier because you have less portlandite. But not the pH. It's not the problem. On the mineral additions, it's not the problem, the pH, but the portlandite. On the inhibitors, you like to respond, and I can complement?
Thank you. Yes, the 5 or 6 weeks of waiting was due to the testing of the product. So the technical sheet of the product stated that their product just gave them more advantage after 5 or 6 weeks, and that's something that we tested. So perhaps you can do intermediate testing, but I think it was not going to have good results. I can give you the product later if you want, in order not to make here some publicity. The chemical is more related with Carmen than with me.
No, I would like to say that you need to measure the corrosion rate. Again, you need to go to the heart of the problem, because if you measure how far it enters, maybe it's not acting. It's not that I don't find that is interesting. You need to measure that you lower the corrosion and that you don't have corrosion afterwards. You measure how deep is entering, maybe it's not acting. In that case, you cannot be sure. And this product lasts some weeks because it needs to reach there and to protect well and so. In that case, how to know the product? Just test it. Apply on a concrete and measure before and after, and it's easy to see the difference.
But it was a specification of the provider, okay? That length of the treatment.
One more question about One more question about the inhibitors. You said it was sprayed, and after 6 weeks you test the measurement if it was working, and it was. The corrosion rate was decreased. But we are considering that in these 6 weeks the inhibitors are reaching the steel bar, or is a surface effect reducing water or oxygen? How is the mechanism these inhibitors are working?
Well, they go inside the volume of the concrete and it reaches the rebars. What you are measuring is the corrosion rate of the rebars. So they have to go inside all the cover you have. Then one of the things that can change in the different points of the structure is the cover. Okay, you have one cover in the drawings, but sometimes it's not so real. So if the rebars are deeper, it needs more time to act. But it reaches the bars.
So in that case, we are having in account that in 6 weeks these inhibitors are reaching the steel bar, and why not the carbonation or chlorides could go this same depth in 6 months? This is the part that I cannot understand. Why the inhibitors?
Te lo dejo.
Well, the inhibitors may have different type of mechanisms of acting. This one that we have tested at the Institute Eduardo Torroja, and we have given a certificate, has been studied there, is a hydrophobe with an inhibitor. In that case, the hydrophobe is able to go very quickly with a quick rate of absorption, and is transporting the inhibitor inside, I mean, because it's there. But this is because it's a hydrophobic agent with big penetration rate.
Okay, we are approaching the end of today's program, and to close the event, we welcome Mr. Miguel Ortega Cornejo, President of the Spanish Association of Structural Engineers, who will share a few final reflections.
Thank you very much. Good afternoon, everyone. And for me, it's a pleasure to join you today at this closing ceremony of the Concreto Day. Events like this remind us of the central role that concrete plays, not only in our profession, but also in shaping the world around us. Concrete is much more than a material. It is in every foundation of our cities, our infrastructures, and our capacity to connect people and places. This is why it is so valuable to come together as a community, to share knowledge, to debate the challenges ahead, and perhaps the most important, to build bridges across generations. The presence of both young professionals and young students and not so young and experienced engineers today is a powerful sign that our field continues to grow stronger, both through the dialogue and collaboration. I would especially like to encourage all the students and young attendees here today to make the most of this opportunity. Don't hesitate to speak now at the end with the keynote speakers, with the specialists, with the professors we have here, and ask them questions and share your ideas. The moments of exchange, often informal, are where real learning and inspiration takes place. Take advantage of this change to connect with them, with the professionals who have walked many different paths in the world of structural engineering, as we have seen through all this morning. And you'll find that most of us, or most of them, are more than willing to listen and to share and learn also from you as well. In my role as president of ACE, the Spanish Association of Structural Engineering, I really want to thank all the all the organizers, to Leonardo, to the Colegio de Ingenieros de Caminos, Canales y Puertos, and to all the entities and the companies that were involved in this event. Really, thank you for having me here. I believe deeply in this spirit of connection between the youth and the experience, and between the research and practice, between the innovation and tradition. And I think our mission is to foster that exchange, to bring together those who design, those who build, and those who investigate with a shared purpose to advance structural engineering in service of the society. I take advantage of these small words to encourage you also to come, if you can, to attend the Congress we will have in June in Granada, between the 25th and 27th of June. We have our triannual Congress that H has. You can type Congreso H on the website, and you will have a lot of information. We will meet more than 400 people, experts, these days there, and we will have also the opportunity to visit Alhambra, and that also maybe just that thing worth it to come to visit us in the Congress. Well, thank you for having me here. Let's keep working together to ensure that concrete, both as material and as a symbol of continuity, remains a cornerstone of our profession and our future. Thank you very much.
Thank you, Miguel. We conclude this second edition of the Concreto Day by passing the baton to our colleagues in Turkey, who will host the 2027 Concreto Day edition next year. And now we invite everyone to join us for a cocktail reception. As Miguel said, a great opportunity to meet the speakers and to connect with fellow professionals. Thank you once again for joining us today, and I wish you a fruitful and enjoyable rest of the day. So now I'm going to ask the partners of the Concreto and the students to stay for a moment, because we are going to have a family picture. Thank you so much.